In this presentation, I'd like to walk through the process of plumbing or hooking up VEX Pneumatic Components and programming it. Well, let's get started. So now that we have the basics of pneumatics and how some of the components work, let's look at some real parts and see if we can't figure out how to use them for our application. So let's go ahead and wipe the board clean, and we'll start off with just some of the simple ones. Okay, so this is our first component that we're going to discuss. This is our reservoir or tank. This is where we're going to store all the air that we're going to use for our project. The compressor is going to be a separate component that we're going to use to fill this tank. So I can see on both ends I have two different fittings. On this end I have a quick connect fitting that my tube is going to connect to that goes out to the rest of my system. And on this end I have a tire pump port, better known as a Schrader valve. So this is the same as it is on your bicycle, same as it is on your car. There's a little tiny pin inside there that the compressor is going to push in, and it's going to fill this thing full of air. To use the quick connect fittings, all we have to do is take a tube and we insert the tube and press it as far as it will go. There's a set of fingers in there that actually expand and then clamp down onto our tube once we start pulling back on it the other direction. So every time we push it in, we want to give it a little tug to make sure that it's completely seated. To get it out, I do the opposite. I'm going to have to push this orange ring in that holds the fingers open, and then I can pull the tube back out. And you'll notice once you've used them several times, you'll actually get kind of a little crimp mark on there. While we're at it, I want to mention how to cut the ends of the tube. We want to make sure that the end of the tube is cut completely straight across so that when it goes in, it'll go in as far as it can. If we cut it at an angle, there's a portion of it that can't go in, and then we can't get quite as good a seal. Okay, so for our reservoir, we're going to have our tube that's going to go out to our system. We've got our Schrader valve on this end that's going to accept air from the compressor, and that's really it for this component. The large nuts that are on each end, these are just to mount it onto something or hold it into the project. That's really all they do. Okay, so for our second component, this is our shutoff valve. One of the things you have to realize is this is only really designed to go one way. There is a cool little picture on here that tells me what's going to happen, and there's also this little triangle that's on here. This little triangle means the air has to come in from this direction. If you bring air in from this direction, it automatically exhausts right back out of it. That's how we bleed the air or get rid of the air that's in the system. When we shut this valve off, all of the air that's in the system that's forward from this will go ahead and exhaust out of here, and it will take the pressure off of all our components. But as far as from this side, to be able to allow it to go through, we have a shutoff. So typically in most valves, when the valve is perpendicular to the path, that means that it's closed. So right now the air will come into the triangle side, it'll hit this wall that's in here, the little door that's closed, and it won't allow it to come out. If the air were to come back from the other side, it'll automatically just drip out of it and it'll exhaust out really quick. Okay, so we want the air to come in from the triangle side. Once this valve is open, then it will allow air to go directly through. Air won't exhaust because this is closing off the exhaust port. It only exhausts when this is in the closed position. So we have an open position and a closed position, and we have an input and we have an output. So that's really it for the shutoff valve. As far as the ports work, it's the same. They just happen to be gray this time. We'll take the tube, we'll place the tube all the way in, give it just a little bit of a pull. We'll go ahead and place this tube in and give it a little bit of a pull, and that's it. So our next two components are both very similar, so we're going to go through them both at the same time. This is our single acting actuator or cylinder, and this is our double acting cylinder or actuator, either way. Okay, so let's go ahead and cover the single one first. What makes this a single actuator? I can see that I only have one input that comes into it. So, I have no air right now, and if I grab this cylinder or the rod and pull it out and let it go, it retracts back in. I have no air, so what is it that pulled it back in? There's a spring that's inside here, and that spring is what's pulling it back and taking care of one of my actions for me. So all I have to do is have air that comes in, and then it will press the cylinder up. So then the question is, well then, how does it get rid of the air that gets trapped in the cylinder? What do I mean by trapped? Okay, so when I press air in from this way, it sends it up, and there would be a vacuum inside there. If I didn't allow air to come back into it, then this would never go back in. It's like kind of putting your finger in the end of a straw inside a cup. You can actually pull the water out of it. So if I can't push air out of it and pull air into it, then this is going to be trapped and it's not going to work. So when I put air into this port and I want to push it out, you'll see that there's actually a tiny little hole on the end of this, and that hole is where air can come into the cylinder and out of the cylinder. And yeah, even though it's that tiny, it's more than big enough to be able to exhaust the air out of it to allow the cylinder to extend and then be able to retract. So there's our single acting cylinder. This cylinder is used when all I need is force in one direction. So when I want to push something and hold something into place, then this one's going to be good. I don't have any force. I have a little bit, just the spring itself, but I don't have much force or a controllable force on the retract end of it. That's the opposite with a double acting. Now this piece here we'll get to here in a second, but I have two ports or two inlets. So I can apply air into it this way and it will send it out. And it'll stay there until I push air into this side. Once I push air into this side, it will send it back. So this is a double acting cylinder, and I can decide how much pressure I want to be able to push and hold with or pull with. So we have a double acting cylinder. So it's this little fitting here on the end. For the most part, we would consider it to be kind of a speed control. It doesn't really adjust my pressure. It just adjusts how fast the pressure can get through it and exhaust. So I can actually change them. If I just untwist this, I can untwist this one and I can change them from end to end. It'll have to do with how fast it will send it out and how fast it will retract. So I can actually place one of these on both ends if I want to be able to control the speed or how much in both directions. Okay, so I can use this little piece. Now on the end of this there is a small straight screw, and as I turn that I can adjust the pressure. If I'm looking at a more industrial cylinder, this speed control valve just has a dial on the end of it. So rather than me actually having to put a screwdriver in there and adjust it, then I can just adjust it a little bit here, and then this has a lock nut on it so that I can spin that down and lock it into place, and then that won't turn anymore. So my air will come in and I can adjust how fast it will go into it or out of it by controlling this little valve that's on the end. So ours is controlled by the little screw that's in the end. For the most part, we'll just leave it alone right now. So if you want it to move slow or fast, we'll use the gold one to do our fast, and we'll use the silver one to exhaust or to retract slowly. So it's up to us. Okay, so we have a single and a double acting cylinder. One direction of controlled force and two directions of controlled force. So here's our next two components. This is our single and our double acting solenoids. So these are electrically controlled valves. So we'll take a look at this one first. So on this side I have two ports. So if I unscrew this, I can see here that I have port P on top and port R on the bottom. So I'll go ahead and screw this back into the P. And then on this side I only have one port and it says A. So P is going to be my pressure. So my pressure is going to come from my tank, and this is an electrically controlled door. So it basically is an electrically controlled shutoff valve. So inside here, when this is not turned on, then there is no air that goes through here. Once I send a signal to it, it'll turn it on, open up the door, and allow the P to go across to the A. Same thing, now that I have my cylinder and I have air trapped inside the cylinder, when I go to retract it, the air has to get out. So once I close this door, that door will open up the valve that will go straight from A over to R, and it will release all of that air into the atmosphere. So that will exhaust. So I don't have to put anything on the R right now unless I wanted to put a speed control valve. I could put an exhaust valve on there that would control how fast I allow the air to come back out of it, and then it would control how fast it will retract. Because it's single acting, I don't typically care how fast it retracts. It's just going to retract at whatever force the spring pushes it back. So my air comes into the P and out of the A, but it only travels across those two when this is on. So when this is on, it allows the air to go from the P and down and over to the A. When I turn it off, then the A travels straight back to the R and exhausts out into the air. So our double acting solenoid. Our double acting solenoid is basically two of these shutoff valves. So if I look on here, I have R, P, R, and I have A, and I have B. So my P is going to be the pressure that comes from my tank. A is going to go to one end of my double acting cylinder, and B is going to go to the other end. And that really depends on whether I want it to be out by default or whether I want it to be back by default. If I remember right, A is the one that's on by default. So when this cylinder is not on, P is going directly over to A. So whatever plug into A is the one that will have the pressure first. And then once I turn this on, it will switch from A to B and allow the pressure to go from B, and then it will exhaust back out. So I have to have an exhaust on both sides. So I have an exhaust for A and I have exhaust for B, whichever one isn't being used. Okay, so this is one of our specialty components. This is a T-fitting, and it just happens to be a push to connect. This T-fitting will allow me to bring air in and then allow that to go back out into two separate directions. Now, the nice part about this specific T is this specific T doesn't have a dedicated inlet to it. So any of these three can be my in, and then any of them I want can be my two outs. So it's a splitter and allows me to take one amount of pressure and split it out into two. We know Pascal's formula tells us that it's going to be equal throughout all of the chambers or all the contained areas anyways. So if I have 80 coming in, then 80 is going to go out both directions. It doesn't split it where 80 comes in and then 40 goes out both directions. It's going to be 80 everywhere. The hole that's here is just a mounting hole that I can put a bolt or a screw through that kind of mounts that into place. So this is one of our specialty fittings. And this is our last component. This is our other specialty piece. This is a pressure control. This dial on the end here, unlike the dial that was used on the end of our double acting cylinder, this still allowed whatever my pressure was. If I had 80 psi, it still allowed 80 psi to get eventually through it. It just slowed down how fast it could get to there. This one does something a little bit different. This will allow me to actually control the pressure or shut it off a little bit. So if I have 80 psi coming up to it, I can allow 40 psi to come out. So this is for something that doesn't need near as much pressure. Now, the really nice part is if my tank is holding a full 80 psi, but I'm only using 40 psi, then I can get a lot more shots or extensions out of the cylinder if I'm using it at a much lower pressure. So it is important that you plug this in the correct way. The port down here at the bottom, that is my inlet. That's where my pressure is going to come from. So for whatever this needs to lead back to our reservoir or the tank. So once that's pushed in, that will control it. As far as this direction, this is going to be whatever I want to control out on the other side, whatever I want to have less pressure than is coming into it. The problem is if you use this thing backwards. If this becomes your inlet pressure and this is your outlet pressure, then it's going to get whatever the maximum pressure is. So if your tank is holding 80 psi, then 80 psi is going to come back out of it. The only way it actually controls the air is when it's coming in from the correct direction. So coming from this direction, it will decrease it to whatever you want. Now, the problem is we can't very well tell exactly what pressure we're getting out of it without some kind of gauge. So that is the only thing that I don't like about this specific fitting is I can't control it specifically. So if I want it to only have 12 pounds of force, then I'm going to have to do a little bit of math with it. I'm going to have to do a little trial and error. I'm going to have to use a force gauge. I'm going to have to use something else that allow me to see exactly what I'm getting. But other than that, it allows me to decrease, or I can't actually increase it. It'll allow me to decrease the amount of air that's coming from the tank, or I can increase it up to its maximum pressure. Okay, let's take a look at our first circuit. We have our tank. We've now filled it from the compressor. We have our shutoff valve. And I'm going to put one more extension tube from the shutoff valve. And I'm going to go straight to the single acting cylinder. So once I open this up, it should extend out my actuator. Okay, so whatever pressure was in here is the pressure that's pushing back. And we can calculate how much force is actually being pushed out on the end of it, or how much force I could push back. Now, I can push back in with that, but I have to be overcoming whatever pressure is being produced by the cylinder. So I know right now if I close this, I'll exhaust, and I heard the air exhaust out of here, so that all the air that was trapped inside here is now exhausted into the atmosphere. So I have the ability to now operate a single acting cylinder. This is the same thing as if I was replacing this with my single acting solenoid. So my air would come in. When I turned it on, the air would come through. When I turned it back off, the air would exhaust back out this bottom R port for the relief. So that's our first circuit. Okay, let's look at our second circuit. Here we have a double acting cylinder. So this one isn't going to be quite as easy. I know right now that my cylinder is in, so I'm going to go ahead and add my extra piece onto my shutoff valve. And I know right now if I came into this one, that's not going to produce any results because it's going to bring air in and it's going to retract this, which it's already retracted. So I'm going to come into the bottom one. And as I do that and open this up, it should go ahead and extend it. I can then close that off, but this time it didn't bring it back because there is no spring. So I can undo this, I can plug it into this end, and I can bring it back. So I can control this, but I don't want to have to keep unplugging the tube, so I'm going to have to build myself a little bit more. So I'm going to scoot the tank just kind of off the screen a little bit. So I have my original shutoff valve. That's what's keeping the air inside the tank. I now need the ability to control two others. So I'm going to bring in two more. So I know I have to plug them in the correct way. So I have my little arrow that means my input. I have my little arrow that means the input, and I now need to split this air off and go in two separate directions. So that's where my T is going to come into play. So I'm going to go ahead and push a small piece in here, small piece of transmission line in here. I'll connect those to my shutoff valves. Give a little tug on everything to make sure that they're all seated, and I'll go ahead and connect this onto my main line. Now, before I ever open up my main line, I want to make sure that these are shut off. Okay, so I want to check everything. So I have a triangle, so direction coming into it, direction coming into it. So the very first time I test this, it will bring air and fill up all of this part and equalize the pressure in there, but I shouldn't lose any. Okay, so I'm listening for any hissing sound. I'm listening for any places where I have any kind of leaks, and right now it sounds like I'm good. So I'll go ahead and shut this back off for now. And I did hear a small amount of exhaust. What I exhausted was what filled up this small T section. So I did just lose a little bit of air, even though I didn't do anything. I brought some air in, I filled that back up, I equalized the pressure, and then I have lost that air. Okay, so now I'm going to bring a little bit longer section. And this one is going to go to my extension. And then I'm going to bring the other one over to my retraction. So now I should have the ability to control this thing. So if I open this one, this is what should extend it. Why didn't anything work? Oh, because my main shutoff valve wasn't opened. Okay, so again, as soon as I open this, it's going to fill up air up to both of these shutoffs. I know I don't have any leaks from earlier, at least I shouldn't still have any leaks, and now let's give it a try. Okay, so we've extended out. I then will have to close this one and open this one. And because I close this one, that's what's allowing this to exhaust back out. If I have both of them open at the same time, it wants to equalize, but there's nowhere for it to exhaust the pressure out. It doesn't like that. So my solenoid itself can't do that. The pieces that are inside, like you saw in the video, it only allows the pressure to go out to one and then release the other one, or the pressure goes out the other one and release that one. So once I have it completely pressurized, then I've got full pressure up against it. So that is now going to be replaced by this one. So here are our two circuits. We have our single acting cylinder. So we basically have the ability to shut off one direction and exhaust. It returns back on the spring. So we've replaced this shutoff valve with a single acting solenoid. and this was our double acting cylinder. So we have our double acting solenoid, which was the ability to control 2 separate directions. So I do want you to make a habit at the end of each day, before we put everything away, to depressurize all of our components. We can put them onto the compressor and get new air and everything the next day. So I know right now with my shutoff valve closed, then there is no air in the rest of the line. So that's also when you want to take things apart. You need to make sure that we have our main shutoff closed, so that there's no pressure in the rest of it. If there's ever a time where it feels really difficult to get one of these pieces apart, that's probably because it's pressurized. It's the pressure behind it is part of what keeps all of these pieces together and keeps this all sealed up. So if any point in time it's difficult to take one of these apart, then that means there's pressure still in it. So for right now, we know as soon as this is closed off, that this should exhaust all of the air that was in the line anyway. So once that's done, I'll go ahead and take the first junction apart that's away from my shutoff valve, and then all I have left to do is to go ahead and open the shutoff valve, and then it will release any of the air that's inside of the tank. Okay, so now I have no air inside the tanks. These are good for the rest of the evening, and I have no air that's inside the line. So that's really it for VEX components. In our next video, we'll go ahead and see if we can't program these pieces and see if we can start doing it automatically. Cool.